Hi, and welcome to this new video in the series on Bluetooth Low Energy technology. My name is Mohammed Afani, and in today's video we'll be continuing our series on Bluetooth Mesh. The topics we'll cover in this video include the provisioning process in Bluetooth Mesh and how security is handled in a Bluetooth Mesh network. The provisioning process is one of the most important concepts in Bluetooth Mesh. It is used for adding devices to the mesh network. A device that gets added to the network is called a node. The provisional is usually a tablet or a smartphone, and the process involves 5 steps. Let's go over each of these steps. Step 1 involves what's called beaconing, where the unprovisioned device announces its availability to be provisioned by sending the mesh beacon advertisements in the advertisement packets. This is a new type of advertisement data type. This process may be triggered via a defined sequence of button presses initiated by the user on the unprovisioned device. When the provisioner discovers the unprovisioned device via the beacons being sent, it sends an invitation to this device. This invitation uses a new type of PDU called the Provisioning Invite PDU. The unprovisioned device then responds with information about itself in a Provisioning Capabilities PDU. Included in this PDU are the number of elements the device supports, the set of security algorithms supported, the availability of its public key using an out-of-band technology, the ability for this device to output a value to the user, as well as the ability for the device to allow a value to be input by the user. Security in Bluetooth Mesh involves the use of a combination of symmetric and asymmetric keys such as the elliptic curve Diffie-Hellman algorithm. In step 3, public keys are exchanged between the provisioner and the device to be provisioned. This is done either directly or via an out-of-band channel. The next step is to authenticate the unprovisioned device. This usually requires action by the user by interacting with both the provisioner and the unprovisioned device. The authentication method depends heavily on the capabilities of both devices used. In one case, called the output out-of-band, the unprovisioned device could output a random, single, or multiple digit numbers to the user in some form, such as blinking an LED a number of times. That number is then input into the provisioning device in some way. Other cases include an input out-of-band, where the number is generated by the provisioner and entered into the unprovisioned device, a static out-of-band, or even no out-of-band. Regardless of the authentication method used, the authentication step also includes a confirmation value, generation, and check. After authentication is complete, each device derives a session key using their private key and the public key sent to it from the other device. The session key is then used to secure the connection for exchange of additional provisioning data. This data includes the network key or net key for short, a device key, a security parameter also known as the IV index, and a unicast address which is allocated by the provisioner. Now the unprovisioned device becomes what's called a node. So let's take a look at a capture of the provisioning process in a Bluetooth Mesh network, captured using the Elysis Bluetooth tracker. Here I have the Elysis Bluetooth Analyzer software open with the capture file open. We won't get into a lot of the details of the packets, but rather focus only on the important ones. The first step in the provisioning process, as we mentioned before, is the beaconing. Here we have an unprovisioned device that wants to join the mesh network. We can see here that the device starts by sending out mesh beacon advertisements. If we look at the details of the advertisement packets, we can see that the data is recognized and parsed, showing that it is an unprovisioned device beacon, and that the device UUID is broadcast as well. The next step in the provisioning process is the invitation. This occurs when the provisioner sends out an invite packet to the unprovisioned device, which we can see here. If we want to look at the details of this packet, we can look at the details pane here, and we can see that this is recognized as the Provisioning Invite PDU. In response to the Provisioning Invite PDU, the unprovisioned device responds with a Provisioning Capabilities PDU, which is captured here. Some of the information sent in this PDU include the number of elements in the device, the algorithms that are supported by the device, as well as the out-of-band support information, such as the methods of the input and output as well. And you can see all this information here in detail, parsed with human-readable format. The third step is the exchange of the public keys between the provisioner and unprovisioned device, which we can see in these two packets here. The next step is the authentication step. As we mentioned earlier, the authentication method depends on the capabilities of both devices, the provisioner and the unprovisioned device. This step involves a random number generation, as well as a confirmation generation and check. The last and final step in the provisioning process is the distribution of the provisioning data. The distributed data is encrypted, as we can see here. Here it shows that the provisioning data is encrypted and we'll need a key in order to understand this data. As we mentioned earlier, the distributed data is encrypted, and it's encrypted using a session key that's only known to the two devices involved in the provisioning process. As a confirmation that the provisioning is successful, a mesh provisioning complete message is sent from the now provisioned device, which also becomes known as a node. The first important note regarding security in Bluetooth Mesh is that it is mandatory, compared to BLE where it's optional and up to the developer to decide whether to include it or not. Here are some of the basics of security in Bluetooth Mesh. First, all mesh messages are encrypted and authenticated. Second, network security, application security, and device security are each handled independently. And third, security keys can be changed during the life of the mesh network, which we'll talk about here shortly. As we mentioned previously, network security, application security, and device security are each handled independently. Due to this separation, there are three types of security keys, each addressing a different concern. First, we have the network key or net key. Now, possession of this shared key makes the device a part of the network, also called a node. There are two keys derived from the net key. These include the network encryption key and the privacy key. A possession of the net key allows a node to decrypt and authenticate up to the network layer, allowing relaying of messages, but not application data decryption. Second, we have what's called the application key or app key for short. This is a key shared between a subset of nodes within a mesh network, normally those that participate in a common application. For example, a lighting system app key would be shared between light switches and light bulbs, but not with a thermostat or a motion sensor. This application key is used to decrypt and authenticate messages. App keys are only valid within one mesh network and not across other networks. Lastly, we have what's called the device key, or dev key for short. This is a device-specific key that's used during provisioning for securing communication between the device, which is the node, and the provisioner during the provisioning process. One major security concern with a mesh network is gaining access to a network via a discarded or removed device that used to be part of the network. This can be accomplished via gaining access to the keys that are stored within that device, and is often referred to as a trash can attack. In order to protect against such attacks, Bluetooth Mesh defines a procedure for removal of a node where the device is added to a blacklist and the keys are refreshed across the network. This process distributes new network keys, application keys, and other relevant data to all nodes except those that are on the blacklist. Another concern is privacy. The way privacy is addressed in Bluetooth Mesh is via the use of a privacy key that's used to obfuscate the message header. The privacy key is derived from the network key or net key. For example, the source address is obfuscated to prevent tracking of a device via its address. The last security concern we want to cover is replay attacks. A replay attack is when one or more messages are stored and replayed later by a malicious device. Bluetooth Mesh provides protection against replay attacks by use of a sequence number SEQ. Elements increment this SEQ value every time they publish a message. So a node receiving a message from an element which contains an SEQ value that's less than or equal to that which was in the last valid message will discard it, since it is likely that it relates to a replay attack. and also by the use of an incrementing IV index, which is an additional value that gets validated when receiving a Bluetooth mesh message. To learn more about Elysis, provider of the world's most advanced Bluetooth analyzers, visit elysis.com. Have a need for training or design services? Then contact our training partner, NovelBits, at novelbits.io. I hope you've enjoyed watching this video and learned a little bit more about BLE. Thank you for watching, and I'll see you in the next one.